Good evening, everybody. It is once again Ted the Speed Learner, and I'm going to talk about trig identities again tonight. What they're wanting you to do in order for us to progress into what we want to get into is to acknowledge that, say, the cosine of negative 60 is the same as the cosine of 60, or the cosine of negative 85 is the same as the cosine of 85. How do you do that? Well, you have to know a few things to do this, and one of them is the law of cosines. Okay. Now, you probably didn't recognize that when you watched my video Euclid Book 2 Proposition number 12, but most of that information was right there. If you look up the exact equation of the law of cosines, it's going to look an awful lot like this. Not exactly, but an awful lot. At least you'll have an idea where they get all this stuff from. Alright, let's go through this here. We have a triangle, and it's BAC. Triangle ABC right here. As you notice, it's obtuse. What is an obtuse triangle? It is a triangle that contains one angle that is over 90 degrees. And as you can see here, this triangle contains an angle right here that is more than 90 degrees. Alright. So now what we've done is we've extended this out to BDC. Okay, so triangle BDC is a right angle triangle, and it is 90 degrees. Okay, so let's go through this briefly, okay. DC squared, okay, so we have to take the length of DC. This is the length of DC. DC squared, which in this case is 4. Okay, the length of DC is 4, so we're going to square 4. Okay, now we're also going to say that DA here is 1. So DA is 1, AC is 3, and the whole length of DC is 4. So the square of DC is equal to the sum of CA squared, which is going to be 3. Okay, I just told you that, it's going to be 3. Plus AD squared. Well, where's AD? AD. Right there. There's AD right there. Okay? And that's going to be 1. Plus 2 times CAAD. Now, this is CA over here, and this is AD right here. So, we're going to multiply the length of 3 times 1, multiply that by 2, add it to all of this, and we'll get DC squared. And I'm going to show you exactly how that works. Now, the first thing is, what is CAAD? Well, if you draw CA as 2 sides of a rectangle, and you draw AD as the other 2 sides of that same rectangle, you'll get 2 rectangles which have a length of 3 and a width of 1. Let me say that again. You're going to have 2 rectangles. Their length is going to be 3. Their width is going to be 1. So this is 2 rectangles, and these are 2 squares. Do you remember when I told you in the Pythagorean theorem that every time you see a superscript of 2, that's automatically a square? Like in square area? There you go. Okay, 4 squared. Where do we get the 4 squared? Because the length of DC is 4. 3 squared. Where we get that? CA is the length of 3. 1 squared, where do we get that? AD is the length of 1. 2 times 3, where do we get the 3? CA is the length of 3. Where do we get the 1? We got the 1 from AD. Okay. Well, 4 squared is 16, 3 squared is 9, 1 squared is 1, and 2 times 3, because 3 times 1 is 3. Okay? 3 times 1 is 3. Down here we have 16. 9 plus 1 is 10. 2 times 3 is 6. Well, 16 does not equal 6. 16, of course, equals... I bet you saw that. You're going, ha ha, look at him, he's so stupid. Okay, well, let's get over the stupid here. As you can see here, 16 equals 16. Because what is 10 plus 6? Well, it's 16, of course. Alright. And then if you continue on with this proof of Euclid Book book 2, proposition 12, you have CD squared plus DB squared. Well, where is DB squared? Well, DB is right here. And we've said that that's 3. DB squared is 3. CD squared plus DB squared equals CA squared plus AD squared plus DB squared plus 2 times CA AD. Where did we get all those numbers? CA squared. Length of CA is right there. That's 3. AD squared, that's 1. DB squared, that's 3. 2 times CA AD. Well, CA is here. AD is here. That's 3. That's 1. That's where we got all that. Okay. So now we have 16 plus 9. Where did we get the 16? Because CD is the length of 16. Where did we get the 9? Because DB is the length of 3, and 3 squared, of course, is 9. Where did we get the 3 squared? Well, 3 squared is CA. Okay, so that's 9. Where did we get the 1 squared? AD is 1. 1 squared is 1. Okay, where do we get the 3 squared over here? Because DB is 3, and 3 squared, of course, is 9. And where do we get the 3? 3 is CA right there. Where do we get the 1? AD is right there. Well, 25 equals 10 plus 9 plus 6. 25 equals 19 plus 6. And 25, of course, equals 25. And I could go on and on and on with this, but I think you're finally starting to get the point here. Based on all of this, and you can follow Euclid Book 2, proposition number 12 if you like, and I hope you do, you'll begin to see everything I said was true. Eventually, what you're supposed to do is you're supposed to make the discovery. I'm going to draw this out here. That what you're going to have is and I hope I get this right. If I don't, write me. I'll make whatever corrections I need to make. That's what you're supposed to see. And from there, what you'll end up doing is you'll get the cosine of negative 60 equaling the cosine of 60. Now, this explanation is not completely done. Okay, I've given you a couple of puzzle pieces. We're getting a little closer to where we want to go. But believe me, I'm not done with this. So this is a continuation here. So I don't want you thinking, well, you have all the pieces. You don't have all the pieces. But we're going to get you to where all the pieces are. All right. So don't get overly excited. The rest of the explanation is going to come. I'll tell you more in a future video. Stay tuned.